All right, in this video, we're going to talk about how to solve limiting reactant problems. These are stoichiometry problems in which more than one reactant amount will be given. So we'll write LR problems for short. And again, these are stoichiometry problems, but more than one reactant amount will be given. And our job is to figure out which of those two is the limiting reactant and which is in excess. And we'll limit our discussion to reactions where there's only two reactants. And we'll write a generic equation of A plus B yields C plus D. And we'll use lowercase letters to represent coefficients. There we go. That's just sort of a general reaction, and we'll refer to A and B as the reactants and C and D as the products. Here's method one. Method number one that we're going to learn to solve limiting reactant problems involves comparing product amounts. By comparing the product amounts, we're going to determine which available amount would give us more product. And the first step here is to pick one product. It doesn't matter if it is product C or product D, but you have to be consistent. And when we get to a later step, you can't compare apples to oranges. Let's say, for instance, we picked product C. The next step is to figure out how much product C will make from the available amount of A and how much we'll make from the available amount of B. So we're going to, for each reactant, convert from amount available to an amount of the product you picked. For each reactant, convert from amount available to an amount of the product you picked. So if you picked C, convert amount available of A to C, then convert amount available of B to C. And actually, this can be done for moles or grams of the product. We can compare either of them. So you might prefer to convert to mole since it's one less step, but the question might ask you to predict the actual or the theoretical yield rather in grams, so you might want to do that extra step. Of course, once we've done step two, we can just compare the product amounts. The smaller product amount corresponds to the limiting reactant. And I'm going to say corresponds because sometimes students will tell me that a product is the limiting reactant. So I'm not going to say the smaller product is the limiting reactant because, of course, a limiting reactant is a reactant, not a product. So make sure you don't make that error. When you're asked to name the limiting reactant, you can't name a product. We're going to talk about one other method next. This first method is especially helpful if you're asked to predict an amount or an actual yield because it involves calculating an amount of product. The next method will allow you to identify the limiting reactant a little bit more quickly. However, it's not going to tell you how much product is produced. And that's because method number two involves comparing reactant amounts. So let's write method number two, compare reactant. And here we're going to look at the available ratio and compare that to the balanced equations ratio. So the first step is to convert from moles of one reactant available, for instance, A, convert from one reactant, doesn't matter which one, available. So for instance, A, 2 moles of another reactant needed. And notice we're starting with an available amount that might be given to us in grams, and we're converting to a needed number of moles. Now we're going to compare the amount of mole B needed to the amount of mole B available. And that means your other amount will need to be converted to moles as well if it's not already given in moles. But if the moles of B needed is greater than the moles of B available, then let's see if you can finish that sentence. If we have more of B needed than is available, then B is the limiting reactant. And that means that A is in excess. There's one more question you may be asked to answer in limiting reactant problems, and that is the amount of excess reactant that will remain. And here's the guiding principle we're going to use. For these questions, you will have already identified the limiting reactant. So let's think about the fact that for the limiting reactant, however much was available, all of that has been consumed. So I'm going to write for the limiting reactant, the amount available minus the amount consumed is going to be 0, right? All of it is used up. But for the excess reactant, the amount available minus the amount consumed will not be 0. In other words, there will be some excess. And this is what we're asked to solve in these problems. We are given the amount available. We are given the amount available for both reactants. Now you've identified which is which. We've calculated how much will actually be consumed of both reactants. And if not, there's a number of ways you can get this value since you've already calculated how much of at least one product has been produced. This is really the value that needs to be solved for. The others are already known. Once you've solved for the amount of excess reactant that is actually consumed based on all the other values we've calculated, just subtract it from the amount available for that excess reactant. So the challenge here is just going to be distinguishing between the limiting reactant and the excess reactant, and make sure you're substituting the values in here correctly and not mixing up one reactant with another.